we have to find the area of DECB, which is a trapezium. With this formula is the formula I'm going to use here will be far, but I will derive it after the solution. That since I have a triangle and I have a constant area 1, this is applicable when the area here is 1. The area here in a trapezium, the area here and here are the same. The opposite area, the area formed by non-parallel sides. Why the product, if you multiply this area, is the same thing as this. So whatever that is here is here. So meaning what will be here is the square of any of this. So I'm saying that whatever that is here, if I call it x, here is x and here is x squared. As you can see, the product of this and this are the same. And the value of x is whatever that is here plus whatever the 1 here over 21 minus 1. So we have 22 over 20, which is 11 over 10. So whatever that is here is 11 over 10. So therefore the area we are looking for, area DECB, is 1 plus 2x plus x squared, which is 1 plus, that's the addition of all these areas. X is 11, so we have 2 times 11 over 10 plus 11 over 10 all squared. So this is 1 plus 22 over 10 plus 121 over 100. So this is 100 plus 220 plus 121 over 100. So our answer is 144. So 441 over 100, which is 4.41. So the answer is option A. So the solution is fast. Let me now derive why x is 11 over 10. So follow up. Look at this. If you notice, this diagram is analogous to this. So our y here is 21, and we have a constant area which is 1 here. So when I will use this formula if the area here is 1. So let's solve. We've not that DECB is a trapezium. So if we call the area here x, the area here is also x. Yes, as far as this is a trapezium, we've proved that in my previous video. And whatever that is here must be square root of the product of this. Do you get? So this should be x squared. I'm saying that if you have something like this and you join the vertices, that if the area here is x, maybe let's call here A, here is A, and here is B and C, that A times A will be also B times C. So that's why x times x is x squared. 1 times x squared is x squared. So that's how this place became x squared. Okay. And again, looking at these two triangles, so I'm going to solve using two similar triangles. The first triangle is triangle. So using ratio of area of similar triangle, if you could remember that ratio of area of, so I'm looking at triangle ADE is similar to triangle ABC. Yes, they are similar, which implies that we said that the area, which implies that area of triangle ADE over area of triangle ABC will be equal to DE squared. Remember, area of DE squared over BC squared. Similar triangle is the same thing as the square, the ratio of the square of the corresponding side. So area ADE is y, so we have y over y. This is, you add all the areas, which is y plus 1 plus 2x plus x squared. Yes, area of this, addition of all the areas, y, 1x, x, and x squared, which is, okay, let's make DE the subject of form. DE over BC, we have DE squared over BC squared. So the square comes here is now square root y over y plus 1 plus 2x plus x squared equals DE over BC. So let's call it equation 1. So again, comparing triangle, we've compared this and this. Let's compare this triangle DEF is similar to triangle BCF. Yes. So again, the same way, ratio of areas of similar triangle, which is area of triangle DEF over area of triangle BCF, will be DE squared over BC squared. Yes. So we have that the area of this is 1, while the area of this one is x squared, which is DE squared over BC squared. So making it the subject of formula is now square root 1 over x squared equals DE over BC. So this is our equation 2. So we have DE over BC here. We also have DE over BC. So we equate the two. So equating the two, so we have that y, let's divide this. We have that y square root y over y plus 1 plus 2x plus x squared must be equal to square root 1 over x squared. Remember, from this, DE over BC is that. Why that same DE over BC is that? So this now equals that. So square root, we have y over y plus 1 plus 2x plus x squared equal to 1 over x squared. We'll cross multiply, so we'll have y plus 1 plus 2x plus x squared equals yx squared. Our main aim is to find x, that's the target. So we have x squared here, x squared here, so it goes over to be y. So this one remains here. We have y x squared. We move elders to the other side, minus x squared minus 2x minus y minus 1 equal to 0. So we factor there is x, so we have y minus 1 x squared minus 2x minus y plus 1. So this is now a quadratic equation. As you can see, comparing using a quadratic from quadratic equation, from as squared plus bs plus c equal to 0, we know that x equal to minus b plus or minus b squared minus 4ac over 2a. So from our quadratic, so if you compare, a is that, b is minus 2, yc is there, so which therefore our x now here is minus 2 plus or minus square root b squared, which is minus 2 squared minus 4 times a, y minus 1 times c. C is what? Minus y plus c. So this becomes plus y plus over 2. A is y minus 1. So which is this plus 2 plus minus this is 4 plus 4. This difference of 2 squared, which is y squared minus 1 over 2y minus 1. And looking at this, we can factor 4. We now have 1 plus y squared minus 1 over 2y minus 1, which is 2 plus or minus square root of 4 is 2. 1 minus 1 is 0, remaining y squared. Square root of y squared is y. But remember, area, was here. But here, x is area. Area should be positive, not negative. So we neglect. So we discard the negative sign. We use only positive. So we have 2 plus 2y over 2y minus 1. And if you factor 2, we have 1 plus y over y minus 1 times 2. So 2, 2. So we now have y plus 1 over y minus 1. So that's our x.